Good day and good health to you all. The topic this video will be covering is the normal distribution curve and its use in AP statistics. The normal distribution curve, or bell curve, not only is it my favorite graph in statistics, but it is also a very useful and very important graph that shows the range and proportion of the dataset. In other words, it shows you where most of your data is centered around, where it is, and how far from that center you can expect most of your data to be. The bell curve is a very particular, very uniform graph, and it can only be used to model populations that have a normal distribution, and your problems should tell you whether or not you're dealing with a normal population. Bell curves are not used to model bimodal populations, which have two modes and therefore two humps, because that's not normal. Bell curves have one mode and one hump, and neither are they skewed left nor right. Skewed graphs are steep on one side and taper off on the other side. The bell curve is symmetric across the vertical axis, so it tapers off on the right side the same way that it tapers off on the left side. When you're modeling a normal distribution with a bell curve, two crucial pieces of information you need are the mean and the standard deviation. The mean is something you're probably familiar with. It's the average of a set of numbers, and it's represented by the Greek letter mu. On the bell curve, the average value goes right smack dab in the middle. For normally distributed populations, the mean is the same as the median is the same as the mode, which is special because that doesn't normally happen with any old dataset, only normal datasets. Since mu also represents the median as well as the mean on the bell curve, half of your data will be above and half of it will be below. The standard deviation is a bit trickier, and you've probably never used it outside of a classroom. It's represented by the Greek lowercase letter sigma, and it measures the deviation, or the spread, of your data. Its value is the length of the intervals on the graph, so sigma equals 2 would mean that each interval is 2 units long. There are two basic concepts involving standard deviations that will help you understand them in context of a bell curve. The first is, the fewer standard deviations away something is from the mean, the more average it is, and the more standard deviations away something is from the mean, the less average it is. To illustrate this, we'll compare the concentration of pigment for coat colors, so basically the pinkness of a population of mus. Japanese mus, not Greek mus. Your original, average mu is this pink color, and the mus to the right are more pink, and the mus to the left are less pink. Now, the mus that are 1 standard deviation away don't differ much from the original mu, but 2 and 3 standard deviations away differ considerably. 3 standard deviations above is a lot more pink than 1 standard deviation above, while 3 standard deviations below is a lot less pink than 1 standard deviation below. So, the more intervals away these mus are, the less like the original mu they are, and the more their coat color deviates from the mean. The second concept is that larger standard deviations mean that your data is spread out farther from the mean, and smaller standard deviations mean that your data is closer to the mean. For example, let's say you work as a waiter or waitress at Pizza Hut, and you've worked there about a month, and you've calculated that the average amount of tips you earn every night is $30, and the standard deviation is $10. So, your graph would look like this. $30 average in the middle, and intervals of 10. So, to the right, plus 10, plus 10, plus 10. To the left, minus 10, minus 10, minus 10. So, your nightly tips range from $0 to $60, which is basically double or nothing. Say that you recalculate after you've been working there a while longer, and you find that your average has risen to $35 a night in tips, and the standard deviation is $5. Now your graph looks like this. $35 as the average, plus 5, plus 5, plus 5, and minus 5, minus 5, minus 5. Since your standard deviation is smaller, 5 is half of 10, your spread is half of what it was. Now it's 20 to 50 instead of 0 to 60. So you have a smaller spread. And the graph is also taller and thinner. This means that the graph is more tightly centered around the mean and provides more useful and clear information. As a side note, the value of n, or your amount of data, your population size, affects the value of the standard deviation. Note the above equation, which we will cover in another video, which affects the shape and spread of the graph. This explains why the standard deviation decreased the more nights you worked. So, that explained the spread of data. Now for the proportion of data. If I said that something was within one standard deviation of the mean, you'd say, great, so it's not very different from the mean. But within one standard deviation refers to 68% of the data. This is because of the 68, 95, 99.7% rule, which states that 68% of your data is within one standard deviation of the mean. So, one standard deviation above or one standard deviation below. 95% is within 2 standard deviations, and 99.7% is within 3. So, more than half is within 1 standard deviation. Most is within 2, and pretty much all is within 3. Anything beyond 3 is special, and very unlikely. Also, the graph is bisected by mu, so, again, half of the data is above and half below. Now, you find the percent for the individual intervals, in this case, the 2 middle ones. You would divide 68% by 2, so they're 34%. The next interval's out. Do 95 minus 68, since you just want the stuff on the ends, not the stuff in the middle. Divide that by 2, so 13.5%. And then 99.7 minus 95 divided by 2, so 2.35%. This shows how the bell curve gets its shape, because of the different proportions in the different intervals. You should probably pause the video here and copy this graph down. It's a good thing to know. Now, to demonstrate, let's go back to our first month of working at Pizza Hut. I want to find out how often I get enough tips a night to buy myself a $20 pizza. Well, that's conveniently 1 standard deviation below. So, 1 standard deviation below and higher is enough to buy me at least one $20 pizza. Referring to the previous slide, all this above the mu is 50%, and this interval here is 34%. So, 50 and 34 is 84. So, 84% of the time, you get enough money in tips to buy a $20 pizza. Hip hip hooray! The next video will cover z-scores, which are like percentages but with cumbersome fractions of standard deviations instead of nice convenient whole numbers. The z-score table, which prevents you from doing 42 years worth of calculations, and this beautiful equation. Thanks for watching, and I hope this helped.